Hello, today we are starting a couple of lessons on revision of ratio, and our first one, ratio 1, we'll be looking at the basics of ratio. Before we begin though, I would just like to highlight this little thing here, my pause button. Throughout this lesson, quite often I will be asking your teacher to pause the lesson and wait for you to do some work and then play the video when you are ready to mark that work. So every time that I say pause the lesson, I want your teacher to pause the video while you get on with the work, and that will be starting in a moment or two. Right, so back to the content of today's lesson. Success criteria: bronze can write a ratio, silver can simplify a ratio, and gold can share an amount into a ratio. What we'll be doing is we'll be running through the recorded lesson, and after that there will be a worksheet for you to do as well. So without any further ado, a quick fast 5 do now. If we can pause the lesson while you have a go and play when you're ready to mark them. Okay, let's see how you've done. 7 squared, 49, 5 squared, 25. Subtract 1 from the other. Answer is 24. Question 2, 1/5 of 20 means 20 divided by 5 equals 4. Question 3, 5 bananas cost 45p. If you divide that by 5, you find the cost of 1 banana, which is 9p. How much do 3 bananas cost? Well, that will be 3 times 9p, which is 27p. Question 4, tickets to the cinema cost £4.80 each. I buy 4. How much change do I get from £20? Two ways of doing it. You could have done £4.80 times 4, which is £19.20, meaning 80p change, or an easier way, you could have seen that out of £5 you'd have got 20p change. So for every £5 you'd have got 20p, 5, 10, 15, 20, 4 lots of £5, 20, 40, 60, 80, 80p change. And question 5, a film starts at 9:25 p.m. and is 105 minutes long. That's 1 hour 45. Add that on to 9:25 p.m. you end up at 11:10 p.m. Okay, let's move on to today's main bulk of today's lesson on ratio. First of all, what is ratio? I need to look at this for a moment. The ratio boys to dogs is 1 to whatever, and the ratio of dogs to boys is something to 1. Well, first of all, we've got more boys than 1 and we've got more dogs than 1. So let us count up, first of all, the number of boys that we've got. We've got 1, 2, 3 boys. So let's write that down. We've got 3 boys. 3 boys. Now we use a double dot, a colon, to represent ratio. And how many dogs have we got? 1, 2, 3, 4, 5. We've got 6 dogs. So the ratio of boys to dogs is actually 3 to 6. That's how we say this, 3 to 6. But we want to write it as 1 to whatever. Can you see a way, a number, a factor of both 3 and 6? What number goes into 3 and into 6? Well, both those numbers will divide by 3. If I divide, let's just move this over here. If I divide 3 by 3, I get 1. And if I divide this side by 3, I have to divide this side by 3. And 6 divided by 3 is 2. So my answer is 1 to 2. The ratio of boys to dogs is 1 to 2, which I can also write as 1 to 2, like so. That's the ratio of boys to dogs. Similarly, if I wanted to do it the ratio of dogs to boys, count up the dogs. There are 6 dogs. There are 3 boys, 6 to 3. I now want to express it in the form something to 1. So I've got 1 boy. I have to divide this side by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So the ratio is 2 to 1, or I can express this using the colon sign as 2 to 1, like so. So this is what we mean by a ratio. It's comparing one set of something with another set of something else. And we can simplify the ratio by looking for a factor, a number that goes into both of the numbers that we've got. So that's what we mean by ratio. Moving on. Right, so a quick one for you to do. What's the ratio of teacups to teapots and the ratio of teapots to teacups? And if you can simplify it so that you've got a 1 in there, that would be even better. So pause the video for a moment, please, and play it when you are ready to continue. Okay, let's see what you've got. Teacups to teapots. We've got 9 teacups, 3 teapots, so it's 9 to 3. Both those numbers divide by 3, giving us 3 to 1. If we wanted it the other way around, teapots to teacups, 3 teapots, 9 teacups, so it's 3 to 9, which simplifies to 1 to 3. Bead patterns. This pattern continues off the page. The ratio of blue beads to red beads is 1 to 2. So that means for every 1 blue bead, there are 2 red beads. 1 blue, 2 red. 1 blue, 2 red. 1 blue, this would be 2 reds, and so on. Some questions for you to have a go at solving. Pause the video, please. Have a go at solving those. And when you're ready to continue, press play. Okay, let's see how you've done. The ratio of red to blue beads. There are 2 red to 1 blue, 2 to 1. If there are 12 blue beads in a complete string, how many reds are there? Well, we know the ratio blue to red is 1 to 2. So if this number of blue is 12, we've had to multiply this by 12. So we have to multiply the number of red beads by 12. There are 24 reds. How many beads are there if there are 30 red beads? This time we're better using the ratio of red to blue, which is 2 to 1. There are 30 red beads, so we have to halve that. Sorry, we have to multiply this by 15 to get 30. We multiply this by 15, so there are 15 blue beads. However, we are actually asked how many beads are there if there are 30 red beads. 30 add 15, there are 45 beads in total. Final question. In a maths class, the ratio of girls to boys is 2 to 1. If there are 18 girls in the class, how many boys are there? So the ratio is 2 to 1. There are 18 girls. 2 times 9 is 18. We've had to multiply this by 9. We have to multiply this by 9. 1 times 9 is 9. So there are 9 boys in the class. Moving on. Writing down ratios. There's another example of a pattern going off the page. We're told the ratio of orange to blue beads. What's the ratio of blue to orange beads? Very simple one. And also consider this question at the bottom, please. Pause the video. Press play when you're ready to continue. Okay, let's have a look. Well, the ratio of orange to blue is 3 to 1. 3 to 1, sorry. We just reverse it for the ratio of blue to orange, 1 to 3. This was the important question on this slide. What fraction of the beads are orange? Why isn't it a third? Well, if we just take one part of this pattern here, where we can see the ratio is 3 to 1, because 3 out of every 4 beads is orange, the fraction that are orange isn't 1 in 3, 1/3, it is 3 over 4, 3 out of 4, 3/4. Okay, so that is what the fraction is, 3/4. And if we just look at this for a moment, where does that 3/4 come from? There are here 3 parts, here there are 1 part, and in total we've got 4 parts. So we've got 1, 2, 3 out of 4, 1 out of 4. So under each of these I could put the number 4 to see what they are as a fraction. 3/4, 1/4. Moving on. Right, some statements here about this block of cubes, such as the ratio of yellow cubes to pink cubes is 2 to 4. I would like you to decide whether or not these statements are true or false. Don't just guess, do some workings to help you. And if you do have time, write some sentences of your own that are true about this particular shape. So at this point, I'd like your teacher to pause the video and to unpause the video to play the video when you're ready to continue. Okay, so the first thing to do when you are working these questions out is to write down the ratio of yellow to pink to blue, which in this case is 2 to 4 to 6. So the ratio of yellow cubes to pink cubes is 2 to 4. Yellow to pink, 2 to 4. That is correct. That is true. The ratio of blue cubes to pink cubes is 4 to 8. Blue to pink is 6 to 4. It's not 4 to 8, so that is false. Half of the cubes are blue. Half of the cubes are blue. We've got 6 blue, 2 add 4, we've got 6 other colours, so half of them are blue. That is true. There are half as many yellow as blue. Yellow, there's 2, blue, there's 6, 2 isn't half of 6, so that is false. Moving on. Some more true or false statements, this time about the bundle of cubes here on the left hand side. Again, pause the video, press play when you're ready to check how you've done. Okay, let's have a look. Right, again we start by making a statement about the number of pink, blue and yellow cubes. There are 14 pink, 2 blue, 4 yellow, and it's worthwhile simplifying if we actually can. Here we can divide each of these 3 numbers by 2 to get 7 to 1 to 2. Now let's see how we can use this ratio to help us answer these questions, decide if they are true or false. A quarter of the cubes are yellow. 14, 16, there's 20 cubes in all. A quarter of 20, 20 divided by 4 is 5, but only 4 are yellow, so no, that is not true. The ratio of yellow to blue to pink, yellow is 4, blue is 2, pink is 14, so that's mainly correct, but that should be a 2, so no, that's not true. The ratio pink to yellow is 7 to 2. Pink to yellow, 7 to 2, that's true. 70% of the cubes in the arrangement are pink. Well, 70%, 10% of 20 is 2. 70% is 7 twos, which is 14. 14 pink, that's true. There are 4 times as many yellow cubes as white cubes. That's false, clearly false, because there are no white cubes. Okay, moving on. Right, another question about cubes. There are 3 times as many green cubes as orange cubes. Will there still be 3 times as many green cubes as orange cubes if you do the following? What I would like you to do is write your answers and also think about them. Don't just put yes, no. Think about them and try and decide why the answers will be yes or no. So if your teacher can pause the video and play when you are ready to mark your answers. Okay, let's see how you've done. Right, so we start by writing down the ratio of orange to green, which is 2 orange to 6 green, which simplifies to 1 orange to 3 green, dividing both numbers by 2. So if we add 2 cubes to each, we would now have 4 orange and 8 green. Well, that's not 3, 8 isn't 3 times 4, so no. Double the number of cubes in each pile. We'd now have 4 orange and 12 green. 12 is still 3 times 4, so yes, that would work. Add 4 to each pile. We'd now have 6 and 10. No. Take 2 cubes from each pile. Well, we'd now have 0 orange, so that's definitely no. Half the number of each pile. Yes, because we'd have 1 orange and 3 green. Now what you may have noticed, the ones where the answer is yes are where we've either doubled or halved. In other words, we've used multiplying. Multiplying by 2, multiplying by a half. So what else can you do to the pile of cubes so that the ratio of orange to green remains as 1 to 3? Well, you could multiply the amount of cubes in each pile by the same amount. You could multiply these by 4 and these by 4, or these by 9 and these by 9. So long as you multiply the number of orange cubes and the number of green cubes by the same amount, the number of green cubes will always be 3 times the same as the number of green cubes, always be 3 times the number of orange cubes. Moving on. Right, are these same or different? Something else for you to consider. Don't just put same, different. Think about why they are the same or the different. Pause the video please, teacher, and unpause when you are ready to have a look at the answers. Okay, let's see. Well, clearly 3 to 1 is the same as 3 to 1. 1 to 3 is the same, but it's just been put in reverse. Think of it as the ratio of orange to green is the same as the ratio of green to orange, just in reverse. Now, this one, making it a coordinate, is the same, it's just a different representation, and you'll meet this kind of representation when we go on to drawing graphs, plotting graphs. Don't worry too much about it for now, though. Now, if you remember, we looked at this as a fraction, 3/4 and 1/4. Well, 3/4 is also 75% and 1/4 is 25%. So this is just a different representation of 3 to 1. Here, if we multiply this by 3, we get 9, and this by 3, we get 3. So this is the same, that's just a simplified version. And 3/1 is completely different to 3 to 1. Okay, completely different. Can you represent 3 to 1 as a bar model? Very poorly drawn diagram here. You would draw the 4 parts, shade the first 3 parts in one colour, and the final part, the 1 part, in a different colour. 3 to 1. And here it is again, just illustrated using a bar model. 3 parts in one colour, 1 part in another colour. This one is definitely incorrect, because we have shaded 2 parts in one colour and 1 part in another colour. The confusion comes because we see the number 3 and a person has split it into 3 parts. That is completely incorrect. Right, so looking here, the same or different, we've got, let's have a look down here and see exactly what we've got. We've got 1 orange, 2 blue, 1 orange, 2 blue, 1 orange, 2 blue, 1/3. This is 1 out of 3 pieces, the same. This is 2 out of 3 pieces, the same. So all these represent the same, all these can be used to represent the number of beads, different colour beads in this particular box. 33 1/3% is just another way of writing 1/3, so we can think of this in the same manner. What have we got over here? We've got 1, 2, 3 orange, 1, 2, 3, 4, 5, 6 blues, 1, 2, 3, 4, 5, 6 blues. Now we can put them together and we can have the 3 oranges together and the 6 blues together, 3 to 6. We've got 3 oranges out of 9 in total, 3 nines. We've got 6 blues out of 9 in total. Again, different ways of saying the same thing. 50%? No, we haven't got 50% of anything here. We've got 1/3 and we've got 2/3, but not 50%. Okay, moving on. Sharing sweets fairly. Tom has some sweets. He wants to share them with as many people as possible, but everyone should have an identical selection. What is the maximum number of friends he can share with? So this is the type of worded question that is becoming more prevalent these days in tests and examinations. I want you to have a go at solving this. Teacher, if you can pause the video please and press play when you're ready to mark the answers. Okay, let's have a look. Right, first off, count up the number of green. We've got 12 green sweets. Number of pink, we've got 4 pink. Simplify the ratio. Each of these numbers divides by 4, giving us 3 to 1. So each person can have 3 green sweets and 1 pink sweet. So that can actually go to 3 friends plus himself. 3 friends plus himself, since we can divide it by 4. Okay, 3 friends plus himself. Moving on. And there's just a picture to illustrate. 3 green sweets and 1 pink sweet each. Simplifying ratios with different units. This can cause a few problems with people. Simplify the ratio 40 pence to £2. So Troy's got 40p, Peter's got £2, and Troy's saying the ratio of my money to Peter's money is 40 to 2. Peter's saying the ratio of Troy's money to my money is 1 to 5. 1 to 5, there's no 1s and 5s in here. Who is correct and why? Have a think about that, please. Write things down if you need to. Teacher, if you can pause the video and press play when ready to continue. Okay, let's have a look. Well, Troy is actually correct. We have to change the units first so that both amounts are in pennies. So Troy's got 40 pennies, Peter's got £2. There's 100 pennies in a pound, so £2 is 200 pennies. So their actual ratio is 40p to 200p. We can ignore the p's and just write it as 40 to 200. Now they will both divide by 10, they'll both divide by 5. The biggest number they'll both divide by is 40. There's 1 40 in 40, there's 5 40s in 200. So it will simplify 1 to 5. The ratio of Troy's money to my money is 1 to 5. Okay, you have to put them into the same units. Slightly trickier. Here are some questions for you to have a go at. Teacher, if you could pause the video please and press play when you're ready to mark the answers. Okay, let's have a look. So, £1.20, 120p, 120 to 30, both divide by 30, 4 to 1. 2,500 millilitres to 5 litres, change this to 5,000 millilitres, both divide by 2,500, giving 1 to 2. Simplify this ratio, change them all into grams, 50. This divides by 1,000 to give 5 grams, and 0.2 kilograms is 200 grams. Then each one divides by 5, giving 10 to 1 to 40. Simplify the ratio here, change them all into centimetres, 60 centimetres, 30 centimetres, 45 centimetres. Divide each one by 15, 4 to 2 to 3. Quite tricky those ones. Moving on again. Simplify in ratios now containing decimals. What number do I multiply 0.6 by to get it to be a whole number? Excuse me. So you cannot leave a ratio with a decimal or a fraction in the ratio. You have to get rid of the decimal or you have to get rid of the fraction. So what can we do here? Well, if we look, we can take 0.6 to 2 and we can get it to 3 to 10. But how do we get from 0.6 to 2 to 3 and 10? Pause the video, have a think about that, press play when you're ready to see if you were correct. Okay, let's have a look. Well, 0.6 to 2, we can multiply both parts by 10. If I multiply 0.6 by 10, I get 6. 2 times 10 gives me 20. And then I can simplify 6 to 20. I can divide each number by 2 to give me 3 to 10. Okay, 3 to 10. We must write the ratio in a whole number form. Another way of doing this would have been to realise that 0.6 times 5 is 3. Just multiplying this number by 5 gives you 3 and this by 5 gives you 10. But if you can't see the number that immediately gets rid of the decimal, then multiply it by 10. Multiply it by 10. Moving on. Right, so I need you to match these. Which ratios on the left are equivalent to the ratios on the right? And when you find the one that doesn't match, you've got to write down the correct ratio that suits it over here on the right. So, teacher, if you can pause the video, this might take a little while, and then unpause the video and press play when you're ready to continue. Okay, let's see how everyone's done. 0.25 to 4. If we multiply this by 4, we get a full one, 1 to 16. 0.8 to 4. If we multiply this by 5, we get 4, and 4 times 5 is 20, 4 to 20. 2 to 5. If we multiply this by 5, we get rid of the 5 on the bottom, giving us 2. This times 5, 2 to 25. This one, multiply this by 3, we get 1 on the top. This by 3 gives us 18, 18 to 1. Even just this bottom one here, which has to be done in 2 stages. Firstly, we get rid of the 5 on the bottom by multiplying this by 5, 3.75 to 1. And then we've got to get rid of the 0.75, and the smallest number we can multiply this by is 4 to give us 15. And 1 times 4 is 4, so 15 to 4. Again, tricky. Orange squash. Orange squash is made by diluting bottles of orange with jugs of water. This is how Ben makes his orange drink. He mixes 2 bottles of orange with 4 jugs of water. And here are 5 more diagrams. Which of these drinks has the same strength as Ben's? What you're looking for is which of these drinks is mixed in the same ratio as Ben's. Pause the video please, teacher, and press play when you're ready to see if your students have got the correct answers. Okay, let's move on. So the ratio that we've got here is 2 to 4. So we're looking for something that is a multiple of 2 and 4. This one, 2 to 1. So definitely not. This one, 4 to 5. No. This one is just straightforward 1 to 1. No. This one, 1 to 2. If I divide both those by 2, I get 1 to 2. So this one is yes. Here, 3 to 4. No. Only this one here was a correct answer. Moving on. Orange squash 2. A new orange squash is made from squash and water in the ratio 1 to 4. Which of these mixtures will have the same strength? Again, if you can pause the video please and press play when we're ready to see if you got this correct. Okay, here we go. So the ratio is 1 to 4, 1 bottle of orange with 4 jugs of water. We're looking for multiples of 1 to 4. Multiplying both by 2, we get 2 to 8, so this is correct. No. Yes, multiplied both numbers by 10. Yes, multiply both numbers by 3. No, no, and yes, multiply both numbers by 5. Moving on. Some more equivalent ratios for you to work out. All of these have got to be equivalent to 1 to 5. If you could pause the video please and press play when you're ready to continue. Okay, here are the answers. 1 to 5. So the second number has always got to be 5 times the first number. So 10 to 50, 11 to 55, 6 to 30, 9 to 45, 20 to 100, all fairly straightforward. This last one here, 5 to 1, we've had to divide by 5, so we have to take 1 and divide by 5, giving us 0.2. That last one a little trickier. Second lot of these, again equivalent ratios. All of these have got to be the equivalent of 2 to 3. Pause the video please and press play when you're ready to mark these. Okay, let's see how you've done. Right, 10 to 15, 40 to 60, 30 to 45 and 18 to 27 are the basic ones. Here we've gone from 2 to 1, so we've divided by 2. So we have to do 3 divided by 2, which is 1.5. And this one over here, 3 to 1 we've divided by 3, and 2 divided by 3 is 2/3, which to 2 decimal places is 0.67. Again, these two with the yellow stars, the trickier two. And the final one of these, this time we're not even told the middle one. You have to start from the top and work it all through. So pause the video please and press play when you're ready to mark these. Okay, let's see how you've done. 12 to 18, both of these divide by 6. So the main ratio that we're working with is 2 to 3. 12 divided by 6 is 2, 18 divided by 6 is 3. We've got 36 here. Well, we can go back to this one. 18 times 2 is 36, 12 times 2 is 24, which is exactly the same as this one over here. For some reason it's been duplicated. 36 times 2 is, 24 times 2 is 48, so 36 times 2 is 72. Here we've had to halve 2 to get 1, so we halve 2 to get 1.5, and the final one, 2 times 50 is 100, 3 times 50 is 150. Okay, so if you just play with different ones, it's not so difficult. But if you just use 12 to 18 all the time, to go from 12 to 18 to 100 to 150 is quite difficult unless you go through 2 to 3. Sharing sweets. Joan shares out some yellow sweets in the ratio 4 to 3. She then shares out some blue sweets onto the same piles in the ratio 3 to 4. Does each pile now have an equal number of sweets in it? Right, quite a tricky problem to think about. You might want to do some little diagrams to help you. If you pause the video, have a think about it, write some things down, and then press play when you're ready to see if you've got it correct. Okay, let's have a look. Not necessarily. If you'd started with the same amount of yellow sweets and blue sweets, then yes, each pile would have the same number of sweets in it. However, if you had different amounts of yellow and blue sweets, then no, you would not have the equal number of blue and yellow sweets in them. Moving on. Right, we're going to look at sharing now, sharing into a ratio. Just one example of this. Peter and Susan have inherited £280 from their aunt. They are dividing the money between them in the ratio 5 to 2. How much does each person get? Now these sorts of questions are very common on GCSE papers, and in fact will appear all the way through between now and when you leave Wintringham. So it's useful to have a number of different strategies at your disposal to deal with these particular questions. We're going to look at two today. We're going to look first of all at the bar modelling way. We are sharing them in the money in the ratio 5 to 2. 5 and 2 makes 7 in all. So we want 7 bars in our bar model. 1, 2, 3, 4, 5, 6, 7. And it's got to total £280. So how many 7s go into 280? What's 280 shared by 7? It's 40. So we can write 40 into each of these bars. 40, 40, 40, 40, 40, 40, 40. Now we can split this in the ratio 5 to 2. We know that Peter's getting 5 lots of these and Susan's getting 2 lots of these. So Peter gets 5 times 40, which is £200, and Susan gets 2 times 40, which is £80. The advantage of this method is it's very easy to see exactly what we're doing. Very easy to see it exactly. However, there is an abstract way of doing this, a purely mathematical way of doing this, which suits other people better, and this is that method. First of all, you add up these shares. 5 add 2 means that we're getting 7 shares in total. We need to know the value of one of those shares. One of those shares is the £280 divided by 7. It's £40 per share. If we just look back to the bar modelling way, there's our £40. One of these shares is £40. Peter's getting 5 of those shares. 5 of those shares. 5 times 40, £200. Susan's getting 2 of those shares. 2 times 40, which is £80. You can use either method to solve these problems, whichever method you prefer, whichever method is suitable to you. Right, I'm going to ask your teacher now to hand out the worksheet which covers ratio. Quite a lot of questions on there which will cover simplifying ratio and sharing in a ratio. Hopefully you've learned a lot from today's lesson, and I look forward to speaking to you again soon. Thank you.